Hi viewers, welcome to Cyber channel. In this video, we are going to learn about Kirchoff's law. What is that? Kirchoff's law. Kirchoff's law. In the previous video, we already learned about Ohm's law. What is that? Ohm's law. Ohm's law. V is directly proportional to I. V is equals to IR. In the previous video. Now, in this particular video, we are going to learn about this Kirchoff's law. What is this Kirchoff's law? It is a law which tells about the current and voltage equations. So this Kirchoff's law is of two types. First one is Kirchoff's current law. Kirchoff's current law we call generally as KCL. Another one is Kirchoff's voltage law. Kirchoff's voltage law we call it as KVL. So first one is Kirchoff's current law, another one is Kirchoff's voltage law. We generally call it as KCL and KVL. And other names of these Kirchoff's laws are Kirchoff's first law, Kirchoff's second law, node law, loop law. These are the different names of these particular Kirchoff's laws. Is it right? So today we are going to learn about this Kirchoff's current law. What is this Kirchoff's current law? So let us go to the topic KCL, Kirchoff's current law. Kirchoff's current law tells only one thing. No current is stored at any point or any node in the circuit. No current is stored in any point or any node or any junction in the circuit. Let us see here. Let us take a node. Consider a node N here. Okay. So there are so many incoming branches and outgoing branches when coming to this node. So let it be like this. So let us assume that these are the branches, different branches. Let it be I1, I2, I3, I4, I5, I6, I7 and I8. So these are the different branches. These are the different branches. So if you observe here, what is our main motive of this law is no current is stored, no electrons are stored at a node. Let it this N be the junction or node or point. Whatever we discuss, we can take these words for that particular dot. So these are all the branches. These are all the branches through the current through the branches. So I1, I2, I3, I4, I5, I6, I7, I8. These are the different branches at this particular node, at this particular junction. So what is our statement? The sum of the currents entering into a node is equals to sum of the currents leaving from the same node. Statement. Sum of the currents entering into a node is equal to the sum of the currents leaving from the same node or the algebraic sum of the algebraic sum of the currents entering and leaving at a node is 0. These are the two statements. So sum of the currents entering into a node is equal to the sum of the currents leaving from the same node, or the algebraic sum of the currents entering and leaving at a node is 0. If you observe this circuit, so how many number of currents are there at a node? 8 currents are there. I1, I2, I3, I4, I5, I6, I7, I8. How many currents? 8 currents. Now, how many currents are incoming? How many currents are outgoing at the particular node? If you take this node as a reference node, see I1, I2, I3, I4 and I8. Oh, sorry, we are taking all the currents as incoming. Let's change the directions. Nothing, we just confused. Don't worry about that. Now see, just by changing the directions of the currents direction. See, I1, I2, I3, I4. See the direction of the arrow towards the node. I1, I2, I3, I4. See, I1, I2, I3, I4. Towards the node. Towards the node. If you observe here, I1, I2, I3, I4, the currents are entering into the node, towards the node, entering currents. We call it as a entering currents. Entering current. And what about the next another one? I5, I6, I7, I8. See the direction of the arrows indicated here. The direction of the arrows are leading from the away from the node. That means those are considered as the leading currents. So I5, I6, I7, I8. Leaving currents. Leaving currents. Away from the node. Away from the node. So I1, I2, I3, I4 are entering currents. I5, I6, I7, I8 are the leaving currents away from the node. We are going to observe, consider the direction of the arrow marks given to the branches. So I1 arrow mark is towards the node, I2 arrow mark is towards the node, I3 arrow mark is towards the node, I4 arrow mark is towards the node. What about the remaining arrow marks, arrow directions? See here, I5, I6, I7, I8 are away from the nodes. Okay. Now, let us satisfying these statements by these currents. Sum of the currents entering into a node is equal to the sum of the currents leaving from the node. What are the currents? I1, I2, I3, I4 entering current. So the sum, let the sum I1 plus I2 plus I3 plus I4. Sum of the currents entering into the node is equals to sum of the currents leaving from the node. What are the leaving currents? I5, I6, I7, I8. I5 plus I6 plus I7 plus I8. So these currents are entering current, these currents are leaving current. Very simple. The sum of the currents entering into the node equal to sum of the currents leaving from the node. Same node. The node should be a same particular node. If you consider, you can take the entering currents and leaving currents at that particular node only. See, the node is never changed. The node should be the same one. Okay. And this is the statement 1. This statement. This statement. What about this statement? The algebraic sum of the currents entering and leaving at a node is 0. So for this one, I1 plus I2 plus I3 plus I4. So just change the signs by changing the direction of the arrows. Take all these things to this side. I5 minus I6 minus I7 minus I8 is equals to 0. So this is the equation for the second statement. This is the equation for the first statement. This all about the Kirchhoff's current law. Thanks for watching.